and magnetism. So this is our first question. Here the question is given as when a proton has a velocity which is 2 I cap plus 3 j cap times 10 to the power 6 meter per second, it experiences a force which is equals to also given in the vector form. This is the first part of the question. When its velocity is along g direction, a g axis, it experiences a force along the x axis. What is the magnetic field? So for the second part of the question, uh, we need to find the direction, and the first part of the question we will use it to find the magnitude of the magnetic field. To solve the first part of our question, we will consider our magnetic field b to be b naught will be the magnitude, and let us consider this to be in minus y axis, so which will give us as minus j cap. You can try using the other direction as well, but this is for this case. Okay, so using the formula, we know that the force on any moving charges in a magnetic field is given as force is charge time cross v cross b. Okay, cross product between the velocity and the magnetic field. So in this case, the force is given as y minus 1.28 times 10 to the power minus 13 k cap. Okay, so I'm not going to write the units since we are going to find magnetic field. So directly we will use the unit of magnetic field. So charge I will be writing as 1.6 times 10 to the power minus 19, and v cross b basically in this case will be 2 I cap plus 3 j cap cross minus v naught j cap. Okay, so this is going to give us okay, so then the velocity is also 10 to the power 6, so which we have to use here now. So for the solving this, what we are going to get, so 1.28, I'm going to keep it like this only, 10 to the power minus 13 k cap equals to 1.6 times 10 to the power minus 19. So the negative sign I will be bringing here. Okay, or you can use it in the cross product as well, it doesn't matter. And then I cross j is your k cap. Okay, if you just keep the minus sign here, it will be minus k cap, again it will come to the front only, so it doesn't matter. So j is basically I cross j is basically your k cap, and then j cross j will be 0 because they both are in the same direction, so the cross product will be 0. So this will give me a 2 b naught k cap. Okay, and then it is multiplied with 10 to the power 6. Okay, so then solving it further, 1.28 into 10 to the power minus 13 k cap. Okay, so this will be minus 1.6 into 10 to the power, and the base are same, the power needs to be added, so 19 minus 19 plus 6 will give me minus 13, and it will be 2 b naught k cap. So and then you can cancel this out. Here in the left hand side also there is minus 13, 10 to the power minus 13, and right hand side also there is 10 to the power minus 13. So the negative sign cancels. Okay, so finally what we'll have, 1.28 k cap. Okay, so and then 1.6 times 2 will basically give me 3.2 b naught k cap. Okay, so if we just talk about the magnitude, we say the comparing the k cap, this one magnitude we can get, um, which implies that b naught is simply 1.28 divided by 3.2. Okay, and b naught will be basically 0.4, and then if we use the SI unit, so everything is in SI, so this will be Tesla, 0.4 Tesla. And if we write uh, with the vector, with the if for vector we can write, okay, so vector equation for magnetic field we can write, which is minus v naught j cap. So in this case it will be minus 0.4 Tesla j cap. Okay, so this is the magnitude of magnetic field. So now let's come to the first part of our question, when a second part of our question. So it is we know that the force is given by q v cross v. Okay, and then we also know we can use to find the cross product of this unit vector using this cyclic way. So if it is I cross j, then it will be k cap. If it is j cross k, it will be I cap, and k cross I will be j cap. But if you go opposite to the arrow, so j cross I will be minus k, and so on and so forth. So here what it has said is that the velocity is in g direction, so which means it is in uh, g direction, which is in k direction. So velocity is k cross, we do not know where the magnetic field direction is, which we have to determine, and the force is in x direction, which is I cap. So look here, and so we cross product between which two vector is going to give me I cap. So basically it is j cross k is going to give us I cap, but already the k is here, so I have to go against the arrow, so that is k cross j, which is going to give me I, but it will be negative sign. So therefore what I can say is I cap equals to k cross of minus j, which is going to give me a minus I. Okay, so magnetic field in that case will be in minus minus uh, y direction. Okay, so magnetic field here will be in minus y axis along. Okay, so along minus y axis. So this is how we solve this problem. Okay, so let's solve another problem. Here the problem is similar to the first one. Here the magnetic field is given, which is 4.0 into 10 to the power minus 3 k cap Tesla. Uh, the force is given, which is here 4.0 I cap plus 3.0 j cap times 10 to the power minus 10 Newton. The velocity is not given, but the charge is given as 10 to the power minus 9 coulomb, and the information is given that the velocity is in xy plane. So that means, so the particle is moving in this xy plane. So any particle, if it moves in xy plane, so if it is x, it is y, so then the velocity of the particle in this plane can be written as vx I cap plus vy j cap. Okay, so now again using the same formula, so force is given by q v cross b, and we will use the information given, which is force is 4.0, okay, sorry, I cap plus 3.0 j cap times 10 to the power minus 10. Okay, it will be equal to 10 to the power minus 9, and here it will be, this is q, and v, it is given as vx I cap plus vy j cap, the cross product with the magnetic field, which is 4.0 uh, k cap. I am going to write 10 to the power minus 3 outside. Okay, so it doesn't matter. Okay, so if I multiply 10 to the power minus 9 and 10 to the power minus 3, I'm going to get 10 to the power minus 12. So 4.0 I cap plus 3.0 j cap equals to 10 to the power minus 10. It will be 10 to the power minus 12. So when you take the cross product between I and k, so we let us again recall the cycle of I, j and k, I to j, j to k, and k to I. So I cross k basically means I cross k, but we are going opposite to the direction, so therefore it will be minus j cap. So I can write a vx 4vx minus j cap plus I, j cross k will give me plus I, so therefore it will be 4 vy I cap. Okay, so now if we multiply, I am going to get 4.0 I cap cross 10 to the power minus 10 plus 3.0 j cap cross 10 to the power minus 10 Here I am going to get, I will rearrange it, I will write 4 Vy I cap to the first, it is multiplied with 10 to the power minus 12, and then plus, okay, so it will be negative sign out here, so because Vx is negative, so it will be 4 Vx uh, j cap cross 10 to the power minus 12. Let's compare the coefficient of I cap and j cap. Comparing the coefficient of I cap and j cap. For I cap, what can I write? 4.0 into 10 to the power minus 10. Here, what do we have for I cap? We have 4 Vy into 10 to the power minus 12. Okay, so I think this 4 and this 4 is going to get cancelled. So Vy will simply be 10 to the power minus 10 divided by 10 to the power minus 12, and Vy here we are going to get 10 to the power 2, or which is equals to 100 meter per second. Okay, similarly compare the for j cap, we compare, so how much you are going to get? So it is 3. Okay, so 3 into 10 to the power minus 10, 3 into 10 to the power minus 10 in the left hand side, and I think in the right hand side we have 4 Vx, okay, in 10 to the power minus 12. So then if you again do, so this will be Vx. If you make the Vx a subject, you are going to get 3 times 10 to the power minus 10 divided by 10 to the power minus 12. So Vx is basically your, okay, 3 and 4 is also here, times 4. So then it will be 3 by 4 into 10 to the power 2, so which is going to give you 70 75 meter per second. So we have the velocity equation in xy plane as vx I cap plus vy j cap. So therefore, if I put the value of vx and vy here, so obviously I think there's a negative sign here, uh, here. So this will be minus 75. So therefore, because here we have, while comparing the coefficient, we have to take care of this negative sign as well, because here the j cap is a negative sign. So minus 75. So lastly, I can write it is minus 75 I cap plus, what is our Vy? It's 100 j cap. And then later on, you can also find the magnitude for the whole velocity. So this is how you solve this problem. Now the third question, it says that a proton, a deuteron, and an alpha particle having same kinetic energy are moving in circular trajectories in a constant magnetic field. If Rp, which is the radius of proton, Rd, which is the radius of deuteron, and R alpha, which is the radius of alpha particle, uh, then, so there are four options given. A first option says the radius of alpha particle and the proton particle will be equal, and these two radius will be less than the radius of deuteron. The second option says that the alpha particle radius will be the smallest, followed by the radius of deuteron, and the largest radius will be of the proton. Third says the radius of alpha particle and deuteron will be equal, and these two will be greater than the radius of proton. And the last says that all the three radius are going to be equal. So what we are going to do here is we are going to express the radius in the terms of kinetic energy, because the kinetic energy in the question it says that it has same kinetic energy, all the three charges. And second information we have, it is moving in circular trajectories, and circular trajectories are only possible when the velocity of the particle is perpendicular to the magnetic field. Okay, so first let's express the radius in terms of magnetic field, and then we'll move on to the all the charges and everything. Okay, so let me keep the question out here. So what is our radius? So radius can be simply be found, because if it is executing circular motion, I can write centripetal force mv squared by r equals to qb, okay, sorry, qvb sine theta, qvb sine theta, and in this case theta is 90, because circular motion is only possible when theta is 90. So and then I say mv squared by r equals to q v. I cancel this v and this v. I will write r as mv by qb. Okay, so it will be my equation one. So next, kinetic energy. Okay, so from this equation, I can also write this mv equals qb. Okay, mr. And for kinetic energy, so in this case, okay, qbr from this equation. Okay, so now, so I will just this is kinetic energy. Kinetic energy, I will simply we know that is given by half mv squared. So now we have to express in terms of the radius. So what I'm going to do, I'm going to multiply and divide by m here. So kinetic energy here will be m squared v squared divided by m. So now let us, if I square both sides, I'll get m squared v squared equals q squared b squared and r squared. So kinetic energy here will be half q squared b squared r squared by m. Now I want to express radius in terms of kinetic energy, so I'll make r as my subject. So 2 km divided by q squared b squared from this equation. And if I remove the square from here, so I need to square root to the other side. So q squared b squared. Okay, now since I have expressed my radius in terms of kinetic energy, so radius is root over 2 km, where k is the kinetic energy. So it here square and the square root will cancel out, so it will be qb. Okay, so this equation we are going to use. So I'm going to call this as equation number 2. Now we know the charges that are given as deuteron. Okay, and okay, so first it is given proton. Okay, then it is given neutron, and then it is given alpha particle. So what are they? So proton has a charge equal to 1 electronic charge. Same with the deuteron. Deuteron is just a hydrogen with one extra neutron and plus one charge. So therefore, it will also have one charge, which is because of the presence of one proton. Alpha particle is helium with two less electrons. So its mass number is 4 because it has two proton and two neutron. So neutron is chargeless, so it will also have uh, the okay. So it will have charge which is equal to two electronic charge because of the presence of plus 2 here, and that is because of the two proton present here. Okay, and now if I talk about the mass, considering the mass of proton and neutron to be almost equal, so there is in proton there is only one mass, so there will be m. Also it will be a 2m for deuteron because uh, there is one proton and then there is one neutron. So basically speaking, because I can there is only one proton, so there is m. So proton plus neutron, which will give me as 2m, and the alpha particle here will have two proton and two neutron. So this will be 2 proton m plus m, 2 neutron m plus m. So which will give us as 4m. Okay, so now here what I'm going to do is now I'm going to see that the magnetic field, they all the three charges are in the same magnetic field strength. So that means B here is constant. Okay, and the kinetic energy is already given as they all three have same kinetic energy. The kinetic energy is K for proton, is K for deuteron, and K for alpha particle. Okay, so therefore the radius will be only be proportional to the mass and will be inversely proportional to the charge. Okay, so for a proton, I will write as Rp. Rp. What is the mass of the proton? Uh, it is proportional to say root over 1 because there is only one proton out here. And what is the charge? It is 1 only, 1 electronic charge. Okay. So, and for the deuteron, what I'm going to write? Deuteron, I'm going to write deuteron proportional to what is the mass? It is basically, so if you wish to write 1m and 1e, it is completely fine. So RD, what is it is? It is what is the mass? It is 2m, and what is the uh, charge? It is I think 1e. Okay, one only one charge is there. And finally for alpha particle it is but 4m, and is it will be how much? It will be charge is 2e electron charge. So now let's take the ratio. So Rp is to RD is to R alpha. Okay, R alpha here it will be simply it will be RP is root over 1. We can cancel out M and E for everyone. So root over 1 by 1 is to see it will be root 2 by 1, and then finally it will be root 4 by 2. Okay, so root 1 by 1 basically mean 1 by 1 is to root 2 by 1 is to 2 by 2, which is also 1 by 1. Okay, so uh, 1 by 1 is to root 2 by 1 is to okay, so sorry, it is 1 by 1. So what is this? This is the radius of proton, this deuteron, and this is alpha particle. So from here we can say that Rp and R alpha are equal, but uh, it is less than what we say the radius of deuteron. Okay, so this will be the correct answer. So let's uh, look for the option above. Okay, so what we have found is that R alpha, and okay, so this the first option will be correct. So this the alpha the radius of alpha particle and the proton is equal, and it will be less than the radius of deuteron. Okay, so we will continue the series in the next video for the next remaining questions.